Hello students, welcome to LearnGuru Classes. So last class we have discussed about how to find one rational number between two rational numbers. Like two rational numbers are there, say x and y, and you are to find out one rational number between these two numbers. So what we have done, we have taken the midpoint and the mean value between x and y gave us the value of one rational number. Okay, so in today's class we are going to discuss about how to find multiple rational numbers between two rational numbers. Now there are three methods of finding rational numbers, multiple rational numbers. So I will show you the first method, discuss the cause of this method, okay, and the limitations of this method. Then we will go to the second and the third method. So with this, let's start our class. So the first problem, let us take this problem as find three rational numbers between 3 and 4. So 3 and 4 are two rational numbers, okay, and you have to find three rational numbers between them. Okay, so what we do, we take 3 points equidistant from one another, okay, x1, x2 and x3 are the 3 points that are equidistant from one another, okay, and you have to find the values of these 3 points. Okay, now you see this value, this x2, can we say x2 is the midpoint of 3 and 4? Yes, we can say. So x2 is what? We can find the mean of 3 and 4. x2 is nothing but the mean value of 3 and 4. So that is 7 by 2. 7 by 2 is the value of the mid value between 3 and 4, or the center point of the two rational numbers 3 and 4. Now come to x1. Okay, so x1 is between 3 and x2, and since all the 3 points are equidistant to one another or at equal distance to one another, so we can say that x1 is the midpoint between 3 and x2. So how we will find the value of x1? x1 is nothing but the mean of 3 and x2. So 3 plus x2 is 7 by 2 divided by 2. So let's go for further simplification. This is LCM is 2. 3 into 2, 6 plus 7 by 2. That is 13 by 2 into 1 by 2. So you are getting as 13 by 4. Now come to x3. Okay, so x3 lies between x2 and 4, isn't it? x2 lies between x2 and 4, and x3, since all the points are placed at equal distances to one another, so we can say that x3 is the midpoint of x2 and 4. And so the value of x3 is nothing but the mean of x2 and 4. So 7 by 2 plus 4 divided by 2. Here LCM is 2. 7 plus 8 by 2, that is 15 by 2 into 1 by 2. So 15 by 4. Okay, so what are the values that you are getting? x1 you are getting as 13 by 4, x2 you are getting as 7 by 2, and x3 you are getting as 15 by 4. So you are getting three rational numbers, and all these three are rational numbers, isn't it? Why it is a rational number, you tell me? So these numbers can be expressed in the form of P by Q, and Q is not equal to 0. So for this it is called as a rational number. So these are the three rational numbers that you can get. But this method has one limitation, is that up to finding three rational numbers, this method will work. But if it is asked to find 5 rational numbers or 7 rational numbers, it will take much more time. Okay, so actually we do not go for this method. Basically we do up to 3 rational numbers. If it is asked to calculate, you can easily calculate. But for getting more rational numbers, sometimes in the exam it may be asked to you find 10 rational numbers between 2 rational numbers. So for that you have to go for a separate method. Okay, so now I will be discussing with you second and the third method. Both the two methods are similar to one another, only a slight difference. So that will also I will be discussing with you, and it depends on you which method you will adopt and write in the exam. So let's look into these two methods. Let's see how the second method and the third method works. So but before going into the second and the third method, one important concept that is associated with this method is the concept of common difference. Okay, common difference. What does this concept of common difference means? So if this concept is clear to you, then it will be very easy for you to solve the problems using these two methods. Okay, now let's consider x is one smaller number and y is one greater number. Okay, now for that I will try to take the example of a train. Okay, where x is the starting point, okay, is a starting place, and y is the final destination you want to travel. So in between, and you are to travel from x to y via a train. Understood? Now these x1, x2, x3, x4, x5 are the intermediate stations between x and y. And all these stations are placed at an equal distance to one another. Mark my word, equal distance. Means what? Distance between x and x1 is d. Distance between x1 and x2 is d. x2 and x3 is d. x4 and x3 and x4 is d, x4 and x5 is d, and x5 and y is x5 and y is d. Means all the points are placed at an equal distance to one another. So if we know the value of d, we can easily find out the values of x1, x2, x3, x4, x5. So this is only the concept. The main concept revolves around finding the value of common difference. So there is a formula of finding the common difference. So what is that formula? D is equal to greater number minus smaller number divided by number of division plus 1. Okay, so number of divisions means the number of rational numbers you want to find out. So in this case, which one is the greater number? Y is the greater number, isn't it? So y. Which one is the smaller number? X is the smaller number. So minus x. Number of division generally we denote it by n. Here it is 5. So 5 plus 1, or we generalize it at n plus 1. So this is the formula for finding the common difference. Okay, so let's take one simple example before solving this problem. Okay, where I have taken two numbers 1 and 2 and I have divided it into 9 equal parts. So this is x1, x2, x3, x4, x5, x6, x7, x8, x9 and this is 2. Okay, so how many number of rational numbers you are to find out? 9 rational numbers you are to find out. So what will be the value of n? N equal to 9. What is y? Y is 2. What is x? X is 1. So how will you find out the common difference? Y minus x divided by n plus 1, that is 2 minus 1 divided by 9 plus 1, that is 1 by 10. So 1 by 10 can be written as 0.1. So if this is 1, this is 2, so this is 1, this is 2, so x1 will be 1 plus 0.1, that is 1.1, 1 plus 0.2, that is 1.2, or 1.1 plus 0.1, that is 1.2. So you are getting 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9 and the last number is 2. Okay, so just I have given you a rough idea how the concept of common difference works. Now using this concept of common difference, we are going to solve 3 rational numbers between 3 and 4 using the 2 methods. So let's have a look at these 2 methods. Let's see how these 2 methods work. So we are going to draw the number line. So this is the number line where we place 3 and 4. So x1, x2, x3 are the 3 points placed at an equal distance to one another. So the distance between 3 and x1 is d, x1 and x2 is d, x2 and x3 is d, x3 and 4 is also d. Okay, so next our duty is to find out the value of d using the formula that I have discussed just now. So d is equal to y minus x by n plus 1. Yes, okay. Now what is the value of y? Y is 4, x is equal to 3 and n is equal to what? 3. Isn't it? So the value of d becomes 4 minus 3 divided by 3 plus 1. Isn't it? So 1 divided by 4 is the value of the d. Okay. Now you see. Let's consider the case of the train that I have used to explain you the concept of common difference. Okay, x1, x2, x3 are the 3 stations. Okay, so 3 is the starting point and 4 is the end point. Now, when you come to x1, you have to start from 3, travel a distance of d and come to x1. Then when you go to x2, what you have to do? You have to start from x1, travel a distance of d and come to x2. So in this case, can I write x1 as x plus d? Yes. Can I write x2 as x1 plus d and x3 as x2 plus d? Yes. So I already have the value of x as well as we know the value of d. So x is 3 plus 1 by 4, that is take the LCM as 4. 4 3s are 12 plus 1, that is 13 by 4. x2 is x1 value already, this is 13 by 4. So 13 by 4 plus 1 by 4. So you are getting 4 for LCM. So 13 plus 1, that is 14 by 4. And x3 equal to x2 plus d, that is x2 14 by 4 plus 1 by 4, that is 4 15 by 4. So you are getting 3 rational numbers. Therefore the 3 rational numbers are what? 13 by 4, 14 by 4, 15 by 4. Okay, so in this way, this is the second method which we use to find out the 3 rational numbers. Now, one magic or the thing that you, if you want to see, now x, this y or equal to 4 is x3 plus d, isn't it? x3 value is 15 by 4, right? Plus d is 1 by 4. So you are getting 16 by 4. So 4 4 just 16, 4. So if all your calculations are correct, you are bound to get the value of the final point by doing another extra division. That is, here you have divided, means here you have added 3 times. x1 you have found out, x2 you have found out, x3 you have found out. But the fourth value, that is the final value, if all your calculations are correct, you will get the final answer. So from that you can judge whether you are doing correct or not, whether your calculations are correct or not. Understood? So this is the second method. Third method is also the same, but there is a slight difference that we make the denominator of both the 2 rational numbers common. So let's check how this method works. Let's check the third method. Okay, so for that, as usual, you have to draw the number line 3 and 4. Okay, and divide the distance between 3 and 4 into 3 points. Take 3 points equidistant to one another. That is x1, x2 and x3. Okay, now the difference is that this is 3, this is 4. Okay, so there are infinite number of rational numbers between 3 and 4, but you have to select only 3 points. So the main thing is that if all the 3 points are equidistant to one another, you have to find, if you can find out the distance between the common points, the mutual points, then that will give us the answer or clue to solve this sum. Okay, so as we already know, the distance between 3 and x1 is d, distance between x1 and x2 is d, x2 and x3 is d, x3 and 4 is d. Okay, so d value we have already calculated from the previous sum, y minus x divided by n plus 1. So y is 4 over here, x is equal to 3 and n is equal to 3, isn't it? So y is 4 minus 3 divided by 3 plus 1, that is 1 by 4. So this calculation you have already done in the last method. Now the difference is that we take the 2 rational numbers 3 and 4. Okay, so 3 and 4 is an integer, right? So how do you express it in the form of rational number? By dividing it with 1. So it implies the same. 3 by 1 is equal to 3 and 4 by 1 is equal to 4. So 3 by 1, now the main thing is that from this you cannot make any clue how to select the or how to pick up the rational numbers. So here what you have to do, you have to make the denominator, mark me, you have to make the denominator of these 2 rational numbers equal to the denominator of the common difference. Okay, again I am telling you, you have to make the denominator of the two rational, once you express this is a whole number or integer, whatever you tell me, 3 and 4 are whole number or integers, isn't it? So 3 and 4 can be expressed as rational number as 3 by 1 and 4 by 1. That much though you agree with me. Okay, now the next step is that you have to make the denominator of both the rational numbers equal to the denominator of the common difference. Okay, so here the denominator is 4. How can you achieve this? Simply by multiplying it with 4. By multiplying it with 4. Okay, now so you have multiplied the denominator with 4. So again this is a rule that you have to multiply the numerator with 4 as well. So what you are getting? 12 by 4 and 16 by 4. Isn't it? 12 by 4 and 16 by 4. Okay, so you have to choose rational numbers in between 12 by 4 and 16 by 4. So how to proceed? How to see? Isn't it? So now again you have to take the help of the common difference. Just like in the previous case, you have added the numbers. 3 can be written as 12 by 4 and 4 can be written as 16 by 4. So x1 equal to x plus d, that is 12 by 4 plus 1 by 4, that is 13 by 4. x2 is x1 plus d, that is 13 by 4 plus 1 by 4 gives us 14 by 4. x3 equal to x2 plus d, that is 14 by 4 plus 1 by 4 equal to 15 by 4. So is the result matching with the second method that I have used? Yes, it is matching with the second method. Okay, so this is how 13 by 4, 14 by 4, 15 by 4. So x4 will be what? x4 is the final point, that is y. Y you are getting it as 15 by 4 plus 1 by 4 divided equal to 16 by 4, that is 4. So you are getting the answer, the final answer, the value of the final point, that is y equal to 4. Isn't it? So you can say that your calculations are correct. Okay, so both these two methods are same, only the approach is different. Okay, here we directly, in the second method, we directly after getting d, we just multiply it with the fraction like 3 plus 1 by 4. But here we try to make the denominator common in both the two rational numbers, and after that we try to find out the rest of the rational numbers using the tool D. Both these two methods are similar to one another, so it's up to you which method you will adopt. Okay, so the more we solve sums, it will be clear to you. So next class I will be taking some examples and will try to solve these problems, solve the problems using both these two methods, and we will check whether these two methods are same or not, whether same results are coming or not. Okay, so we will do these things in the next class. So I am ending the lecture here. If you find this video useful to you, please subscribe to LearnGuru Classes, like and share it with your friends and relatives. Thank you so much.